Welcome to solverfy.
So the total force on the proton is given by the equation Q times E plus V cross B. Now for the first part there is no mention of any electric field, so this will just be equal to Q times V cross B. Now at t equals to 0, we are given that velocity, so we are given the components. So Vx is equal to 1.5 times 10 to the power 5 meter per second. Vz equal to 2 times 10 to the power 5 meter per second, and Vy is given to be equal to 0. So we use these values in this equation, and we know that B is just along the x direction, so there is no component of By or Bz. So then F will then be equal to Q times Vxi cap plus Vzk cap, because Vy is 0 here, and then cross product with Bxi cap, where Bx is basically this value. And then this is equal to Q times Vc Vx j cap. Now we solve this using the values we have. So we know the charge over here. Bx is basically 0.5 Tesla, and Vz or Vz is 2 times 10 to the power 5 meter per second. So we solve this for force, and we get this value to be 1.6 times 10 to the power minus 40 Newton, and the direction is along the y direction. So this is the value of force. Now for the second part, where there is the electric field. So the electric field exerts a force in the direction of the electric field, because the charge on the proton is positive, and electric force is Q times the electric field. So if the charge is positive, the electric force is going to be along the same direction as the electric field. So there is a component of acceleration in this direction. Now for part C, so in the plane perpendicular to B vector, so B here, B vector is, B is along x direction, so the plane perpendicular to B will be the YZ plane. So in the YZ plane, motion is circular, as we know, but there is a velocity component in the direction of B. So in that case, motion is a helix. So this case is when there is no velocity along the direction of B, and if there is a velocity along the direction of B, the motion is a helix. Now the electric field in the x direction exerts a force in the x direction, because the charge is positive. Now, this force produces an acceleration in the x direction, and this causes the pitch of the helix to vary now. The force does not affect the circular motion in the YZ plane, so the electric field does not affect the radius of the helix. So, yeah. Now, for the last part, we use omega is equal to the magnitude of the charge times the magnetic field over mass. And we know that time period is equal to 2 pi over omega. So using these two equations, we get T is equal to 2 pi m over the magnitude of Q times the magnitude of the magnetic field. So we solve this and we get this value to be 1.312 times 10 to the power minus 7 seconds. Now at time t equal to the time period over 2, which means at time 6.56 times 10 to the power minus 8 seconds. So Vox is gonna be same, which is equal to 1.5 times 10 to the power 5 meters second, and acceleration along x direction will be Fx over m. So Fx, let's calculate Fx. So I'm just gonna write the same equation over here. So Ax is Fx over m by Newton's law, and this is basically Q, the charge, times electric field over m, and we know the magnitude of charge, and we know the value of the electric field, and we know the mass. So mass is basically, I'll write it here, so 1.67 times 10 to the power minus 27 kg. This is the mass of the proton. So we use those values to solve for the acceleration along x direction, and we get that value to be 1.916 times 10 to the power 12 meter per second square. Now we use our kinematic equation, which is x minus x naught is equal to v naught x times t plus half ax t square, to find the value of x minus x naught. So we basically have all the values of the constants that we need. So we have ax here, v naught x here, the time we also have. So we use those values in this equation and we get x minus x naught to be equal to 1.40 centimeter. So this is the x component of the displacement of the proton from its position. So x naught is the position at t equals to 0, and x is the position at t equals to time period over 2.